Tunisia, February 1943. The desert air trembles with the echo of fading gunfire. Smoke drifts lazily across a scorched wadi where steel beasts lie crippled in the sand. A German Panzer IV idles beside a strange silhouette. Rounded turret, boxy hull, tracks wide and clean. It is an American M4 Sherman, captured almost intact after a brutal skirmish near Kasserine. German tank crews circle it cautiously. The machine seems crude at first glance. Too simple? Too soft-edged compared to the sharp mechanical elegance of their own panzers? One sergeant kicks at the side armor. It rings hollow, unremarkable. But when the hatches open, they pause. The inside is spacious, logical, almost elegant in its function. Radios neatly mounted, ammunition stored safely below the turret. Controls labeled clearly enough that any crewman could learn them in hours, not months. A mechanic wipes the dust from the engine casing. He studies the design, frowns and whispers, "Das ist clever." For the first time, they begin to understand that this simple tank is not a weakness. It is an idea built not for perfection, but for victory through production, repair, and relentless momentum. That realization, quiet, dawning, will soon define the entire war. By early 1943, the war in North Africa had become a vast proving ground for every weapon the modern world could build. From the burning passes of Tunisia to the open sands near El Gueter, tanks from Britain, Germany, and now the United States clashed daily across the desert. Each engagement was more than a battle. It was an experiment in steel, speed, and endurance. The Americans were newcomers to this brutal theater. Only a year earlier, the U.S. Army had been largely untested in large-scale armored warfare. Their arrival in Operation Torch in November 1942 brought fresh troops and machines across the Atlantic. Among them was a tank that would come to symbolize America's war industry, the M4 Sherman. At the time, Germany's panzer divisions held the advantage in combat experience. Crews who had fought from Poland to Stalingrad now faced a new enemy whose strength lay not in finesse, but in numbers and adaptability. Rommel's Afrika Korps, though exhausted and undersupplied, still wielded tactical superiority. They believed the American tanks were crude imitations of British designs, unsophisticated, hastily built, unlikely to last in real war conditions. But the Sherman was different. Born from American pragmatism, it embodied a philosophy alien to German thinking. Instead of the mechanical complexity of a Tiger or Panther, the Sherman offered something else: ease of production, reliability, and a brutal kind of efficiency. It was not designed to win duels one-on-one. It was designed to be everywhere, all the time. As the fighting intensified in the Kasserine Pass and along the Mareth Line, that difference became impossible to ignore. U.S. factories were already producing over 1,000 Shermans a month. Every tank destroyed in Africa could be replaced several times over. Every crew lost was quickly retrained, every part interchangeable across thousands of machines. To German officers used to hand-tuned precision and limited numbers, the idea was disorienting. The Americans were waging an industrial war, one fought not only by soldiers but by welders, engineers, and assembly line workers thousands of miles away. Behind every Sherman in Tunisia stood Detroit, Pittsburgh, and Chicago, cities that never slept, feeding the front line with steel and oil. And as the Afrika Korps discovered, fighting that machine meant fighting the weight of an entire continent. In captured intelligence reports, German analysts began noting a pattern. The American tank industry functions on an industrial scale previously unknown in warfare. They did not yet realize that the simplicity they mocked was the core of that scale. Soon, when one of those tanks fell into their hands intact, they would finally see why. The M4 Sherman was born not from a single designer's vision, but from a committee's relentless practicality. In 1941, the United States needed a tank that could be mass-produced, repaired in the field, and shipped across oceans. Engineers from Chrysler, Ford, and Fisher Body came together to make it happen. Not elegant, but effective. The result was the M4 medium tank. Its core was simple: a welded or cast hull, a 75mm main gun, and an air-cooled radial aircraft engine adapted for land use. It was a machine that could be built by unskilled hands, maintained by any crew, and started even after sitting for weeks in the rain or sand. Every part, from the bogie wheels to the drivetrain, was interchangeable between factories. It was the first truly modular tank in history. In the field, this simplicity became its secret advantage. American crews quickly learned that if something broke, they could fix it with parts from another Sherman, or even improvise with scrap metal and ingenuity. German tanks, by contrast, demanded precision parts and trained mechanics. In the desert, that difference was survival. By late 1942, Shermans were arriving in North Africa faster than the British could unload them. The British Eighth Army, weary from years of desert war, eagerly replaced its aging Grants and Crusaders with the sturdy American newcomer. It wasn't perfect. The 75mm gun struggled against heavy armor, and its high profile made it an easy target. But its mechanical reliability and speed won admiration among Allied tankers. German Panzer units first encountered the M4 in significant numbers during late 1942 engagements around El Alamein. Reports sent back to Berlin noted the tank's resilience. Enemy armor continues to operate despite repeated hits. Fire control and coordination appear efficient. Yet, these observations were often dismissed as isolated incidents. The Wehrmacht remained confident that superior training and tank design would offset American mass production. That belief persisted through the early months of 1943 until the day a German recovery unit stumbled upon an M4 left largely intact after a skirmish. Burned but not destroyed, its systems remarkably preserved. The decision was immediate. It would be recovered, dismantled, and studied. When German engineers at the front began opening the panels, they found something that defied their expectations. No complex gearing systems, no fragile electronics, no ornate craftsmanship. Instead, they saw functional layout, rugged mechanics, and an almost deceptive simplicity that belied its effectiveness. The discovery would spread quickly through Panzer command circles. What they held was more than a tank. It was a mirror reflecting the American war philosophy: reliability over refinement, mass over mastery. And that philosophy was about to reshape the battlefield. When German engineers finally examined the captured M4 Sherman in detail, they began to see it not as a curiosity, but as a revelation. The first angle that struck them was technological. The tank's internal systems reflected a design philosophy they had never embraced. The engine, adapted from an aircraft radial, was rugged, forgiving, and easily serviced in the field. Its transmission, though unsophisticated compared to German counterparts, could be repaired without returning the vehicle to a workshop. Even the suspension system, using bogie wheels and simple coil springs, could be replaced in hours by the crew itself. To German eyes, this was shocking. They were used to tanks that demanded specialists, machines that required perfection to function. The Tiger and Panther were mechanical masterpieces, but they were also temperamental. Their transmissions overheated, their engines consumed fuel and oil at alarming rates, and their maintenance time sometimes exceeded their operational time. The Sherman, by contrast, seemed built to keep moving, no matter what. Its parts were standardized to such a degree that field depots could strip one wreck and revive another. A tank army that can rebuild itself, one captured German mechanic reportedly remarked. That idea, machines designed for war's chaos rather than for peacetime precision, was something new. The second revelation came on the tactical level. German tank commanders had expected the Americans to fight as the British did, dispersed, cautious, and predictable. But the Shermans, arriving in coordinated platoons supported by fast communication networks, fought differently. Each tank was radio-equipped, allowing American units to maneuver in ways German panzers could not easily counter. Orders flowed instantly. Ambushes dissolved before they could be sprung. Where German units relied on flags or runners, American tankers responded to a commander's voice in real time. In early 1943, during the engagements around Kasserine, this communication advantage became painfully evident. German patrols observed that American armored columns could reform and counterattack within minutes after contact. It wasn't just the number of tanks, it was the speed at which they acted. A captured field report from Panzer Regiment 8 summarized the shock. The enemy tanks are crude, but respond rapidly to command. Coordination between vehicles is exceptional. The Germans didn't yet realize that this came from a broader system. Radios produced in staggering numbers, standardized across all armored units, and built into every Sherman from the factory floor. The tank was not a mechanical marvel. It was an operational network, and for the first time, the Wehrmacht began to sense that they were fighting not just an army, but an industry capable of thinking in systems. That realization would deepen as they explored not only the Sherman's machinery, but the minds behind it. The more the Germans studied the M4 Sherman, the more they realized that its power wasn't in the steel, it was in the people and system that built it. The human angle revealed something both humbling and unsettling. American crews were not elite soldiers forged through years of mechanized warfare. Many were mechanics, farmers, or factory workers just months before. Yet they adapted quickly. The Sherman's logical interior design, the labeled controls, standardized instruments, and comfortable ergonomics allowed men with minimal training to master it in weeks. German tank crews, by contrast, trained for months to operate their intricate panzers. Each man specialized deeply in one system. The American tank, however, empowered its crew through simplicity. A gunner could drive if needed, a mechanic could fire the main gun, and anyone could replace damaged parts. The Sherman made the crew adaptable, and in war, adaptability was survival. Captured reports from German officers often carried a note of grudging respect. The American soldier does not appear technically refined, yet he understands his machine completely. Behind the sarcasm lay an unspoken truth. The Americans had built a tank that turned ordinary men into capable tankers with astonishing speed. Then came the industrial angle, which redefined the scale of war. German analysts could scarcely comprehend the magnitude of American production. While Germany struggled to build a few hundred panzers a month, the United States was manufacturing thousands of Shermans, each identical to the last. Factories in Michigan and Ohio operated around the clock, their assembly lines producing tanks faster than the Wehrmacht could destroy them. The captured Sherman in Tunisia had markings from a Chrysler plant. Another, found months later in Sicily, bore serial plates from Ford. The Germans soon realized that these were not competing manufacturers. They were synchronized. The parts from one could fit the other with no modification. This level of industrial unity was unheard of in Germany, where tank builders like Henschel, MAN, and Daimler-Benz each followed their own designs and standards. For German commanders, this was a chilling revelation. Every destroyed Sherman was a temporary victory. Every German loss was permanent. The Americans could absorb losses and return stronger, while the Axis bled dry under the weight of limited resources and over-engineered machines. Finally, the psychological angle emerged. The Sherman's presence on the battlefield began to wear on German morale. The tank seemed endless, appearing again and again, often faster than destroyed units could be replaced. Its flaws mattered little when quantity and reliability kept it rolling forward. We kill one, 3 appear. A Panzer crewman wrote in his diary after the Sicily campaign, "They come like waves, and they never seem afraid." The M4 had become more than a machine. It was a symbol of America's willpower, its capacity to turn industry into momentum, and its ability to make simplicity into a weapon. The Germans had captured one tank, but what they truly discovered was a nation's method of war. And soon, that method would reach its most violent test yet, in the battles where Shermans and Panzers would meet face to face. By the spring of 1943, the desert was turning against the Germans. The Afrika Korps, worn thin by months of fighting and cut off from supply, faced a relentless enemy that no longer fought like an amateur. The Americans had learned from defeat at Kasserine Pass, and they had returned with vengeance. At the heart of that return was the Sherman. Thousands now poured through North African ports, joining British and Free French units for the final push toward Tunis. The Germans, who once mocked the tank's simplicity, began to fear its consistency. Every encounter felt the same shape, the same sound, the same relentless advance. There was no variety to exploit, no weak design batch to target. The Sherman was the embodiment of uniformity, and uniformity meant predictability, both for its users and for its factories. At Kasserine in February, the Americans had been overwhelmed. Their armored tactics had been disorganized, their commanders inexperienced, their tanks misused in piecemeal assaults. Rommel had cut through them like a knife. But by March, the Americans were fighting differently. They attacked in coordinated waves, supported by artillery and air power, and every Sherman seemed to arrive with fresh fuel, ammunition, and communication. Logistics, the unseen battlefield, had become America's deadliest weapon. In one engagement near El Guetar, German Panzer IVs lay in wait, hidden behind rocky ridges. When the Shermans advanced, they opened fire with deadly precision. The first volleys tore through the leading American tanks, their armor no match for the 75mm high-velocity shells. Smoke filled the valley. American crews bailed out under fire. For a moment, it seemed like another German triumph. Then came the sound. The rumble of engines, not fading but growing louder. A second line of Shermans crested the ridge. Then a third. Within minutes, the valley was filled with American armor, coordinated and unshaken. Artillery began pounding the German flanks, radio directed from forward observers inside the tanks themselves. The ambushers became the hunted. By day's end, the Panzer Regiment had withdrawn, leaving behind disabled machines and scorched sand. German officers were stunned not by the quality of American armor, but by the sheer persistence of it. "Their losses do not matter," one field report read. "They always return with more." This was the turning point. The Germans had captured an American tank months before and dismissed its design as primitive. Now they understood its brilliance. It was not meant to survive every battle. It was meant to ensure the army survived the war. The desert campaign would end within weeks. In May 1943, Axis forces in North Africa surrendered, nearly 250,000 men taken prisoner. And among the wrecks that littered the dunes, countless Shermans stood ready to move again, patched, refueled, and heading for their next war. But the lesson of Tunisia was not the end of the story. It was only the beginning of the Sherman's evolution, its transformation from a desert brawler into the backbone of the Allied advance through Europe. From the moment Allied troops landed in Sicily in July 1943, the M4 Sherman became the face of the advancing war machine. It rolled ashore on Italian beaches, engines humming, tracks grinding over the remnants of Axis defenses. The Germans, now fighting on homeward soil, faced an enemy that had learned not only how to build tanks, but how to fight wars of momentum. The simplicity that once drew laughter from German engineers now became their torment. In the steep terrain of southern Italy, complex German armor broke down frequently. Spare parts were scarce. transport lines harassed by Allied aircraft. Yet the Shermans climbed mountains, crossed rivers, and returned to battle day after day. Each tank that faltered was cannibalized to repair 3 more. For the American forces, nothing was sacred, except movement. German crews began to dread the sight of the Sherman's silhouette. Its armor was still vulnerable, its guns still modest, but its presence meant a tide of men, machines, and air support. The U.S. Army's coordination between armor, infantry, and aviation reached new heights. Every Sherman carried a radio. Every platoon could summon artillery or fighter-bomber strikes within minutes. What the Germans once viewed as technical inferiority had become a tactical ecosystem. Fast, flexible, unyielding. When the Allies landed in Normandy in June 1944, that lesson reached its ultimate expression. Over 6,000 Shermans would cross into France in the following weeks, flooding the bocage with armor that never seemed to end. German gunners destroyed them in droves, yet new ones arrived before the barrels cooled. For every Panther that outgunned a Sherman, 5 more Shermans flanked, surrounded, and destroyed it. Quantity had become its own form of quality. One German officer near St. Lo wrote in his report, "We kill them, and they return the next morning. They are like the war itself, endless, impersonal, unstoppable." The Sherman's weakness was now revealed as a strength born of philosophy. The Germans had sought the perfect tank, an instrument of dominance. The Americans had built the perfect tool, an instrument of endurance. By 1944, American production lines had delivered nearly 50,000 Shermans. Each one was a statement. War was no longer about mechanical artistry. It was about the science of supply, the rhythm of repair, and the will to sustain losses and keep moving forward. In France, in the Ardennes, in Germany itself, the lesson learned in Tunisia echoed again and again. The Sherman was not the best tank. It was the best weapon for the war America chose to fight. A war of attrition that industry, not genius, would win. When German crews captured one in Normandy and opened its hatches, they no longer scoffed. They understood. Every bolt, every wire, every simple switch represented a kind of power their nation could no longer match. And as the Allies drove eastward, that understanding turned into resignation. The era of the perfect machine was over. The era of the endless machine had begun. By the war's final years, the M4 Sherman had become more than a tank. It was a phenomenon. It fought on every front, from the hedgerows of Normandy to the volcanic ridges of Iwo Jima. No other armored vehicle in history would be built, shipped, and fought in such staggering numbers. The statistics alone told the story. Over 49,000 produced, nearly 20 variants, thousands more supplied to Britain, the Soviet Union, and Free French forces. It was a single design turned into an entire global family of war machines. German records from 1944-45 show a growing sense of dread about this industrial tide. Reports from the Eastern Front described Soviet units fielding American-built Shermans under Lend-Lease. On the Western Front, every Allied push, whether in Italy, Normandy, or the Ardennes, was driven by columns of M4s, their engines roaring in unison. The Germans found themselves surrounded by the same tank, repeating like a mechanical echo across continents. Combat data told the truth in cold numbers. A Sherman might take 3 or 4 losses to destroy a Panther or Tiger in direct battle, but for every Panther built, America could field 10 Shermans. In practice, this meant that tactical victories for the Germans turned into strategic defeats. A battlefield cleared of Shermans at dusk would be filled with them again by dawn. German engineers studying captured Shermans during 1944 sent increasingly anxious memos to Berlin. One, dated August 1944, warned, "Enemy armored production exceeds Axis capacity by a factor of 8. Replacement speed renders attrition tactics ineffective." Hitler demanded more Tigers and Panthers, each more complex and resource-intensive than the last. But the numbers did not lie. A Tiger tank required over 300,000 labor hours to build. A Sherman, fewer than 50,000. Germany was trapped by its own engineering pride. To Allied commanders, the Sherman was not a masterpiece. It was a tool that could be multiplied endlessly. General Omar Bradley famously said, "The Sherman may not be the best tank, but it's the best tank to have the most of." Every logistical train, every repair depot, every oil drum behind the front existed to feed that principle. In the summer of 1944, the Allies' armored divisions could lose 100 tanks in a week and still advance. The Germans could not afford to lose 10. The outcome was inevitable. The captured Sherman that had once fascinated German crews in Tunisia had long since been forgotten. But the lesson it taught had become prophecy. Simplicity, standardized production, and reliability were weapons in themselves. As the Allies crossed into Germany in early 1945, even the most loyal Panzer officers knew the truth. The war was being won not in duels of armor and gunfire, but in the factories and supply lines that fed them. And still, the Sherman rolled on, carrying the war to its conclusion. In the ruins of Germany, 1945, the Sherman rolled past wrecked cities and shattered bridges that told the story of an empire undone. The once feared Panzer divisions were ghosts, their Tigers and Panthers abandoned for lack of fuel or spare parts. Along the roadsides, burned-out German armor stood silent, symbols of a nation that had built too perfectly for a war that demanded imperfection. When Allied engineers and intelligence officers examined the battlefields, they saw the full consequence of American design philosophy. The Sherman's simplicity had been a decisive factor in maintaining the Allied advance. Where German supply columns stalled for days awaiting specialized parts, American repair crews rebuilt tanks in the field. Mechanics cannibalized damaged hulls, swapped engines, welded armor patches, and sent machines back into combat within hours. Captured German officers confessed disbelief at the scale and speed of these operations. One report from April 1945 noted, "Enemy repair capacity functions as a parallel production line at the front." That observation was no exaggeration. Every Allied armored division had mobile workshops capable of restoring hundreds of tanks a month. The Sherman's modular design made it possible. Even post-war analysis by German generals reflected this grudging respect. Heinz Guderian, father of the Blitzkrieg concept, would later remark that the American tank program demonstrated an understanding of industrial war unmatched by any other power. The Americans, he observed, did not seek the perfect tank. They built the sufficient tank perfectly. The legacy extended beyond the battlefield. The Sherman became a diplomatic and cultural symbol, a tank that liberated nations. Thousands were sent to Allied countries in the post-war years, fighting again in Korea, the Middle East, and even into the 1960s. Its silhouette, once mocked by the Wehrmacht, became the outline of victory itself. In Germany's own archives, the captured Sherman from Tunisia remained catalogued as Beutepanzer M4A1, a curiosity once studied for weaknesses. Its technical notes now read like a historical irony: uncomplicated, economical, serviceable. Words, once written as criticisms, now stood as epitaphs to a lost cause of over-engineering for the men who had once examined that first captured Sherman, those desert veterans of the Africa Corps. The war ended not with a shot, but with an understanding. They had seen firsthand that war in the modern age belonged to those who could think in systems, not machines, and from the factories of America to the farthest battlefields of Europe. Anan and Senfid Ries du Anford. The M4 Sherman had proven that lesson beyond doubt. In the calm that followed the storm, the lesson of the M4 Sherman stood clear, a truth forged in oil, steel, and sacrifice. The Germans had sought superiority through engineering genius. The Americans had found it through the art of practicality. The Sherman was never the strongest nor the most feared, but it was the most faithful. It carried men across continents, endured their mistakes, and outlasted the perfectionists who built tanks too beautiful for war. In every battle, it embodied a simple creed: fight today, repair tonight, fight again tomorrow. That rhythm, repeated across thousands of fields, became the heartbeat of Allied victory. Behind every Sherman stood welders in Detroit, machinists in Ohio, and factory lines running without rest, a nation that had transformed its economy into a weapon. For German tank crews, the realization came too late. They had captured the Sherman expecting to find weakness, and found instead a philosophy, a way of waging war that measured success not in precision, but in persistence. The war would end, but the idea would endure. Modern armies, from NATO to the present day, still echo the same principle. That power lies not in the perfect machine, but in the system that sustains it. The captured Sherman of Tunisia rusted away long ago, its steel scattered by time. Yet its legacy remains, etched into every army that builds for endurance rather than elegance, every nation that learns the quiet strength of simplicity. In the end, that was America's secret weapon all along.